In this video, we will discuss the product and quotient rules of differentiation. We already know the sum and difference rules. That means the derivative of the sum is the sum of the derivatives, and the derivative of the difference is the difference of the derivatives. So people may guess there is a product rule looks like this. The derivative of the product is the product of the derivatives. The question is this formula correct? Let's study this by looking at an example. For example, if we pick f of x equals to x and g of x equals to x squared, we want to find the derivative of the product of these two functions. We are going to use two methods. The first method is to use the formula we guessed. That is, the derivative of f times g equals to the derivative of f times derivative of g. So by the power rule, the derivative of f is 1 and the derivative of g is 2x. So the answer is 2x. For the second method, because f and g are both power functions, we are going to simplify f times g before we take in the derivative. So the derivative of f times g equals to the derivative of x times x squared. And x times x squared is x to the cubic. So by the power rule, the derivative is 3x squared. So now we have two different answers for the two different methods. Because the derivative of a function is unique, there must be one method that is wrong. So the question is, which method is the incorrect one? Actually, mathematicians have proved that the derivative of the product f times g is not simply the product of the derivatives. Instead, it is the derivative of f times g plus f times derivative of g. So it is a sum of two terms where each term is a product that has derivative to a single function. So if we use this new formula to redo the previous example, finding the derivative of this product, it equals to the derivative of the first term times the second plus the first times the derivative of the second function. So by the power rule, it is 1 times x squared plus x times 2x. If we simplify this expression, we will get the answer is 3x squared. This result confirms the result of the method 2, and the method 1 is wrong. That is because this formula is not correct. So we need to remember this correct product rule. Let's look at another example, finding the derivative of e to the x times x squared. By the product rule, it equals to the derivative of the first term times the second term plus the first term times the derivative of the second term. So the derivative of e to the x is e to the x itself, and the derivative of x squared is 2x. So we can factor out e to the x and get the final answer is e to the x times x squared plus 2x. Similar to the product rule, the derivative of a quotient is not simply the quotient of the derivatives. In fact, the quotient rule is that if f and g are both differentiable functions and g of x is not equal to 0, then the derivative of f over g equals to the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, then divide by the denominator square. You cannot switch the order of these two terms. A tip to memorize this formula is that if you compare the numerator part of this formula with the product rule, you will find the only difference is this subtraction instead of the addition in the product rule. Now let's use the quotient rule to find the derivative of e to the x over x squared. It equals to the derivative of the numerator times the denominator, subtract the numerator times the derivative of the denominator, then divide by the whole denominator square. The derivative of e to the x is e to the x, and the derivative of x squared is 2x, and x squared to the square is x to the fourth, which is the solution. The last example is an application of the product and quotient rules. If f of x is x squared times another function h of x, and the g of x is x to the fifth divided by h of x. For that h of x, we only know its value at 1 and its slope at 1. We need to find the derivative of f at 1 and the derivative of g at 1. The idea is that we find f prime at general x and the g prime at general x first. Then we substitute 1 into the expressions to find f prime 1 and the g prime at 1. So first f prime x is the derivative of x squared times h of x. By the product rule, it is the derivative of the first term times the second term plus the first term times the derivative of the second term. So the derivative of x squared is 2x, and the derivative of h of x is h prime x. Now we substitute 1 into every x to get 2 times 1 times h of 1 plus 1 squared times h prime at 1. Because h of 1 is 3 and h prime 1 is 4, we get the final answer is 10. For g prime x, it is the derivative of x to the fifth over h of x. So the derivative is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, then divide by the whole denominator square. This is the quotient rule. So derivative of x to the fifth is 5x to the fourth, and the derivative of h of x is h prime x. Then we copy h of x squared in the denominator. Now we substitute 1 into every single x. We get 5 times 1 to the fourth times h of 1 minus 1 to the fifth h prime 1 divided by h of 1 to the square. Because h of 1 is 3 and h prime 1 is 4. We then get the answer is 15 minus 4 over 9, which is 11 over 9. So we get the final answer is f prime 1 is 10 and the g prime 1 is 11 over 9. In summary, we learned two important formulas, the product rule and the quotient rule.